Okay, hi. We are going to learn how to do Punnett squares, and we're also going to learn the difference between ratios and percentages that are made by these crosses of different types of parents. So first, learning how to do Punnett squares. We need to make sure we're good on homozygous and heterozygous so we can get the terminology down. So we've got heterozygous. Remember, hetero means different. So that means we're going to have two different alleles. That means we're going to have one dominant allele and one recessive allele. So remember, we denote a dominant allele with a capital letter, and we're going to go with B's this time because they're easy to tell the difference between. So we've got capital B and a lowercase b. Heterozygous, two different alleles, one dominant, one recessive. Okay? Homozygous means that we're going to have the same alleles. So that can be broken down into two types. We can have homozygous recessive, and that would be little b. And then we have homozygous dominant, which would be big B, right? Still the same allele, but one of them is both recessives, one of them is both dominants. All right. So how to do these crosses, called a test cross, when you test what the possibility of offsprings would be. So let's start off with two heterozygous parents. So we've got one parent, heterozygous, two different alleles, big B, little b, big B, little b. All right, the first thing you want to do is make your square and divide it in 4. And we know we're crossing two heterozygous parents. So what you do is you put one allele, start with the first parent, put one allele on top of each box. So one dominant allele here, one recessive allele here. Then you take the other parent and you go down the side, one dominant allele, one recessive allele, because they're heterozygous. Oh, and for demonstration's sake, why don't we make one parent be black ink and the other parent be blue ink so we can tell the difference. All right, so big B, little b. So what you do, there's basically two ways to do this. I'll run through both of them. You can either start with one letter and fill it in every box that it's like in a line with. So this one you would fill in this first box and the one below it. This letter you would fill in going down. So you'd put a little b and a little b. And the reason why I put those little b's over here on the right side is because when you have a heterozygous organism, you always write it with the capital letter first and then the lowercase. So I did that over there just to make sure I have room for these capital B's to go in. All right. Then what you would do if you're using this method is you would take the alleles on the side and you fill them in going right this time. So you put this big B in, and then you go over to the next box and you put the big B in. And then you take this allele and you put it in both of the boxes in a line. So you put the little b here and the little b there. The other way to do this would be to, first you gotta draw your box. It's kind of a small box. Okay, put your alleles up. The other way to do this is to fill in the boxes individually. Oh, make this parent blue. Big B, little b. So you can look at this box and say it's going to be this big B and this blue big B. This box is going to be a big blue B and a little black B. And then this box would be this big black B coming down and the little blue B going over to the side. And then obviously that means this last box is going to be little b and little b. So either way works, right? So that's how you fill them in. Let's do another example. I'm going to stick with this first example for filling them in for the first couple of ones, and then I won't narrate my filling in, and I'll pause a little bit to let you figure out what you think the boxes should have in them. All right, so let's practice crossing a homozygous dominant parent with a homozygous recessive parent. So think about what those genotypes are going to look like for a second. And yes, we're going to have a homozygous dominant with a homozygous recessive. Okay, so you got to draw your Punnett square. And we put the first parent up on the top and the second parent going down the side. Okay, so I'm going to take this big B going down and this big B also going down. And then this little blue B off to the side, and this blue B to the side as well. All right, let's do one more practice. Let's cross a heterozygous parent with a homozygous recessive parent. All right, so we gotta draw our boxes, put the first parent up on the top and the second parent down the side. Okay, and then we fill them in. Why don't you go ahead and fill them in on your guided notes before I do it? Okay, so that's going to end up looking like this. Little b, little b, big B, little b, little b, little b. So that's what it should end up looking like. Okay, so now I feel like you should be good on filling in the Punnett squares. So let's talk about what it means. Now, let's remember the difference between genotype and phenotype. So a genotype is the actual letters here. So those are the genetic makeup of an organism's, like their genes. So that's going to be the letters, is the easiest way to say that. So genotype would be dominant homozygous if we're talking about this genotype right up here. Phenotype is the allele that gets expressed. So that's going to be, a phenotype is going to be blue or brown, whatever you can see. So in this case, most of the time when you see a big B and a little b, you're assuming that we're talking about brown eyes over blue eyes. We know that brown eyes are dominant. So if we have this genotype, which is dominant homozygous, that means the phenotype, what we see, is brown. We see brown eyes, right? So if we have a genotype that is homozygous recessive, then we see a phenotype that is blue. Okay? So let's stick with the brown eyes, blue eyes for all these, and all that's written in the Punnett squares are the genotypes. the possible genotypes of the offspring of these parents. So first, let's talk about what the phenotypes are for each box. So we have here this phenotype and this homozygous dominant offspring. The phenotype is going to be brown. So let's do all the phenotypes in green. So this will be brown. This phenotype would also be brown because we have the dominant gene, dominant allele, excuse me. This offspring is also going to have brown eyes. Its phenotype is brown. And this phenotype would be blue. So there's two ways to report the chances of your offspring having whatever types of genotypes and phenotypes. You can talk about a genotypic. Let's skip over the genotypic versus phenotypic. You can have a ratio or percentages. So right now, if we wanted to say the genotypic ratio of this cross right here with the two heterozygotes, we would count up how many of each genotype we see. So we have one, sorry, had some technical difficulties there. So all the genotypes that you see, let's just do ratio right now. Let's erase that word percentages. All the genotypes that we see in this test cross as a result are homozygous dominant, we see heterozygotes, and we see homozygous recessive. All right. So we count up how many we have of each. So we have only one that is this genotype, homozygous dominant. We have two that are heterozygous, 1, 2. And then we have one that is homozygous recessive. So then, ratios are reported with little colons in between, like that. So all you do for your ratio is you just say 1 to 2 to 1. So this is our genotypic ratio. Ratio, not ration. Ratio. Genotypic ratio of crossing two heterozygotes is going to be 1 to 2 to 1. That's how you say that. All right? So if we wanted to do a phenotypic ratio, notice this Punnett square right here is also two heterozygotes. All right? So if we wanted to do a phenotypic ratio, why am I doing ratio? All right? We first write down all the phenotypes that we have. So let's review this one up here. We have brown and we have blue. Brown. And how many blues? So if we look up here, we've got 1, 2, 3 boxes that have brown phenotypes, and we have one box that has a blue phenotype. Oops, 1. So the phenotypic ratio of crossing two heterozygous parents is going to be 3 to 1. Right? Now we can also report percentages. Okay. So what is the percent in this Punnett square of babies that could possibly have brown eyes? So you count them up, 1, 2, 3. So that's 3 out of 4 total equals 75%. All right, and that's where we're going to stop. We'll pick up on the differences between the ratio and the percentages in class on Monday. So be prepared for that, as well as a bunch of Punnett Square practice. Okay, bye.